Java, a powerful and versatile programming language, shapes the digital world in countless ways. From smartphones to complex systems, Java is everywhere, powering applications and services we use daily. Learning Java is like gaining a superpower, allowing you to create software, apps, and much more, opening doors to endless possibilities. At its core, Java relies on precise instructions to tell computers exactly what to do, step by step. Think of it as a recipe where each line of code represents a specific step, guiding the computer through a process. One of the essential concepts in programming is the ability to repeat actions efficiently and effectively. That's where loops come in. They enable us to execute a block of code multiple times without writing it repeatedly, saving time and effort. Instead of typing the same line 10 times, a loop can do it for you, making your code more efficient and easier to manage. Java provides different types of loops, each with its unique strengths and use cases, allowing for flexible programming. Get ready to unleash the power of repetition and efficiency with Java loops and take your coding skills to the next level. In Java, the for loop is our go-to tool when we know exactly how many times we want to repeat a block of code. Think of it as a pre-planned itinerary for a trip. The syntax of a for loop is structured for clarity. It consists of 3 parts: initialization, condition, and increment or decrement. The initialization sets the starting point of our loop, often using a variable like I. The condition acts as a gatekeeper, allowing the loop to continue as long as it remains true. Finally, the increment or decrement part updates our loop variable after each iteration. Let's illustrate this with an example. Say we want to print the numbers from 1 to 5. Our for loop would look like this: for int I = 1, I = 5, I++, system out, println ni. The beauty of the for loop lies in its simplicity and control. While the for loop excels at predetermined repetition, it isn't always the best choice for every scenario. Java offers 2 other loop structures, while and do while, for situations where we want to repeat a block of code based on a condition that might change during the loop's execution. These loops provide flexibility in controlling the flow of the program. The while loop checks the condition first, ensuring that the code inside the loop only runs if the condition is true. If the condition is true, the loop's code executes. This allows for dynamic control over how many times the loop runs. This cycle repeats until the condition becomes false, making it ideal for scenarios where the number of iterations isn't known up front. Let's imagine we're building a simple game where the user has to guess a secret number. This is a perfect use case for a while loop. We can use a while loop to keep asking for guesses until the correct number is entered. Int secret number = $7, int guess = 0, while guess = secret number, / code, to prompt the user for a guess and store it in the guess variable. This loop continues until the user guesses the correct number. The do while loop, on the other hand, executes the loop's code at least once before checking the condition. This guarantees that the code inside the loop runs at least once. For instance, let's say we want to ensure a user enters a positive number. This is where a do while loop shines. Int number, do / code, to prompt the user for a number and store it in the number variable. This ensures the user is prompted at least once. While number = 0, this loop continues to prompt the user until a positive number is entered. Section 4. Diving deeper, understanding nested loops. In programming, we often encounter scenarios where we need to work with multidimensional data or create complex patterns. This is where nested loops come into play, loops within loops like layers of an onion. Let's visualize this with a classic example. Printing a rectangle of stars, int rows = 4, int columns = 5, 4, int I = 1, I = rows, I++, 4, int j = 1, j = columns, j++, system.out.print, asterisk, system.out.println, / move to the next line after each row. Section 5. The switch case, a different path for decision-making. While if-else statements are great for handling a few possible conditions, Java provides the switch statement as a more elegant and efficient solution when dealing with multiple choices. This is especially useful when the number of conditions is large, making the code more readable and easier to manage. The switch statement evaluates an expression and compares it against multiple case values. Each case represents a potential match for the expression. If a match is found, the code block associated with that case is executed. This allows for a streamlined approach to handling multiple conditions. The break keyword acts as a signal to exit the switch statement after a successful match. Without break, the program would continue to execute the subsequent case blocks. Let's say we're creating a program that simulates a vending machine. This is a perfect scenario to use a switch statement. We can use a switch statement to handle different product selections, making the code more organized and easier to follow. Int choice =2// assume the user selects product number 2. This variable will be used in our switch statement. Switch choice case 1//. This is where we start defining our cases. System out println you selected a pack of chips // This message is displayed if the user selects option 1. Break case 2// moving on to the next case. System out println you selected a chocolate bar // This message is displayed if the user selects option 2. Break case 3// and now for the third option. System out.println you selected a bottle of water. Break default system out.println invalid selection // The default case handles any invalid input. Section 6. Combining loops and switch cases. Real-world applications. Loops and switch cases are powerful tools individually, but their true potential shines when combined. Imagine you're building a text-based adventure game. You can use a loop to keep the game running until the player decides to quit. Within the loop, you can use switch cases to handle different player actions, such as moving between locations, interacting with objects, or battling enemies. Here's a simplified example. Boolean game running =true, while game running // code to display the game world and prompt the player for an action. Switch player action case move // code to handle player movement. Break case interact // code to handle player interaction with objects. Break case quit game running =false. Break default system out println invalid action. Section 7. Conclusion: mastering the building blocks of Java. Mastering loops and switch cases is like learning the alphabet of Java programming. These fundamental concepts provide the building blocks for creating efficient, adaptable, and powerful applications. By understanding their syntax, behavior, and potential applications, we unlock a world of possibilities in Java programming. Keep exploring, keep coding, and watch as your Java skills flourish.